Greetings to you all. Today we are going to be talking about the spanning tree protocol. So let us start with a brief description of spanning tree protocol and its working mechanism before we go into the service configuration and looking at the particular modes we can have this protocol run. So let's say, for example, manager's PC wants to communicate with desk 1 PC in the Surface Desk network. The manager's PC has a MAC address table that maps a MAC address to an IP address. So the manager might know the IP address of desk 1, but the manager's PC doesn't have the MAC address of that particular PC in its MAC address table. So when the manager sends out, for example, it's a ping packet, so it will send the packet will go with the destination MAC address of all Fs. So what happens when the access switch receives this MAC address? So it sends this MAC address to all the ports except the one it has received the packet on. So on a network without link redundancy, that wouldn't cause something called a broadcast storm, what spanning tree tries to eliminate. So once it receives that broadcast packet with the destination MAC address of all Fs, so it will send the packets to all the ports on the switch, except that has been received on. So once we have link redundancy and we have not deployed the STP protocol, this creates something called a broadcast storm. So spanning tree protocol is there to stop this broadcast storm from occurring, as they waste network bandwidth and affect network performance. So today we're going to be looking at particularly the different modes we can have spanning tree deployed. The spanning tree has 3 modes: STP, then you have rapid STP, then you have the multi-instance STP. Multi-instance STP that uses multiple instances. That is a little bit advanced. We shall look at it later in the course's time to come. So what you're seeing these labels in yellow, so they are the labels I'm going to be using for our spanning tree. So as you can see, I have RD. This is the root bridge, supposed to be RB, sorry. RB, not RD. So this is supposed to be the root bridge, and this is going to be our backup root bridge. So these are the designated bridges, these ones. So these ones control the spanning tree. So this one is configured as a primary, and this one is configured as the secondary backup. In case this one fails, this one will take over the role of the spanning tree. So we have different types of ports when after I've configured the spanning tree. So this is the root port that connects us, for example, from this access switch perspective. This is the root port because it is connecting it to the root bridge. Then this is the alternate port that in case this port fails, packets will be forwarded through core 2 to reach the root bridge. Same applies to this. This is the root port. It connects this designated bridge to its the root bridge, and the alternate port still is used to connect this switch to the root bridge in case this particular link fails. Then these are called edge ports, so you can change them from to edge ports. You can change them, you can configure them as edge ports so that they cannot take part in the spanning tree calculations. So that also improves the network performance. So if you know that those particular ports are going to be connected to only endpoint devices, you just configure them as edge ports so that you can improve the STP calculation. So with that, let us go in the service configuration. So we shall come to our core switch 1. Why isn't it responding? So if it's a display STP brief. So as you can see, these are all designated ports because this is our root bridge. Yeah, it doesn't connect to any other switch to act as its root. So this is the root bridge. So here we're going to, how do we set the mode? So we shall say STP mode. By default, Huawei configures its switches with is it a rapid spanning tree. So here I'm going to use a rapid spanning tree because it offers fast convergence and failure detection. So we're going to configure that. Then this is called switch 1. We are going to make it our root STP, root bridge, root primary, sorry. So this is our primary. Then we shall come to call switch 2 and do the same. STP mode rapid spanning tree. Then we shall send the STP priority root root secondary. Just in case our core switch 1 fails, this will take over the primary role and as we work on the core switch 1. So if we display spanning tree protocol brief, you can see that our ether channel, which is these links that we bundled together, that we made the link aggregation on in the last video, are our root port because we are using them to connect to the root bridge. Okay. Then these ones are designated ports. This and these are designated ports. So we go to the access switch 1 and do STP mode rapid spanning tree. So if we display spanning tree protocol brief, so you can see that gig 001 is our root port, which is this, right? This is gig 01 is our root port because it's connecting to the root bridge, and gig 02 is our alternate port. So this is our alternate port, which is connecting to core switch 2. Then core switch 2 connects to the root bridge. So if we shut down interface gigs 0, let's say that particular link fails, do shut down. So and we display our STP brief, you can see that gig 02 has taken over the role of being our root port and it's now in state of forwarding. So if we undo shutdown on this port and we display STP brief, you can see that now again it has switched to alternate and gig 01 is back to forwarding. Okay, that's okay for access switch 2. We shall do the same here. STP mode rapid spanning tree, then display STP brief. So as you can see, gig 001 is our alternate port. Probably that's the port connecting to core switch 2. And yes, and gig 02 is our root port as it is here, and it's connecting to our core switch. Let us fail this switch to see how these things. First save. Just to be quit, exit, then save. So I will do a reboot here. So as you can see, display STP brief. So as you can see, the gig this core 2 has taken over the role of being the primary, and now our alternate port is our root port, and core switch 2 is acting as our primary switch. So once this switch comes up again, to take over the role from gig from the core switch 2 after everything has been resolved. So briefly, so that's what we can talk about. That's just a brief description of spanning tree protocol. It's an important protocol because once you have broadcasters on the network, its performance degrades, and there's a lot of overload on the network device, on those particular network devices. So it is key to have it configured in order to improve network performance and avoid broadcast storms that can cause service outage. Thank you for watching this video. See you in the next video. So you can try out with other modes except the multi-instance protocol, which will be the multi-instance based spanning tree protocol, which we'll be looking at in later time to come. So you can go ahead practice with the rapid spanning tree protocol, which is mostly widely deployed, rather than its earlier version, which is the STP, which offers slow convergency. So in this video, we looked at the rapid spanning tree protocol. Thank you for viewing and consider subscribing. See you in the next video.